In this video, I'm going to show you how to find the equation of an ellipse by completing the square. First of all, what is the equation for an ellipse? Well, an ellipse takes the following form in an equation. It goes x minus h, the quantity, squared, all over a squared, plus y minus k, the quantity squared, all over b squared, is equal to 1. Let's also refresh on what the parts of this equation mean. First of all, h comma k, that is the center of the ellipse. So that's what h and k tell us. Now how about a and b? Well, the larger of a and b is the length of the semi-major axis. So a and b are both constants, and whichever one is bigger gives us the semi-major axis, which is half the length of the major axis. Likewise, the smaller of a and b is the length of the semi-minor axis. So suppose that a is the larger of a and b, then the semi-major axis has length a, meaning that the full major axis has length 2a, and moreover, because a is paired with x here, that means the major axis would lie parallel to the x-axis. So the ellipse would be very wide horizontally. And since b would be the smaller of a and b, the minor axis would lie parallel to the y-axis because b is paired with y. So the ellipse would be a very kind of horizontally wide and vertically short ellipse. On the other hand, if b were the larger of a and b, then the major axis would lie parallel to the y-axis, again because b goes with y here. And that means the ellipse would be vertically very tall. And in this case, a would be the smaller of a and b, and that would tell us that the minor axis lies parallel to the x-axis. So the ellipse would be horizontally narrow. So we'd have a vertically tall and horizontally narrow ellipse. Alright, so that's our refresher on the equation of an ellipse and what all the parts of the equation mean. And now let's get into the meat of this lesson. Here's our question. We want to find the center and lengths of the major and minor axes of the following ellipse: 4x squared plus 9y squared minus 40x minus 18y plus 73 equals 0. So this equation is actually an equation of ellipse, even though it's not in the form that we see up here. And in order to pick out the center and the lengths of the major and minor axes of this ellipse, we actually need to convert this equation into this ellipse form where it's easy to see the center and the lengths of the semi-major and semi-minor axes. So how do we do this? How do we get from this equation to an equation that looks like this? Well, I'm going to show you how. Our first step here, very first step, is to factor out leading coefficients of x and y. So why don't we write the equation again, but grouping up our x and y terms. So we'll have our 4x squared, but then we'll put our minus 40x, and then we'll have our plus 9y squared, then we'll put our minus 18y. And let's also subtract the 73 over to the other side. So we just have equals negative 73. And now we can go ahead and factor out those leading coefficients. So looking at the x terms first, 4x squared minus 40x, the leading coefficient there is 4, because that's on the highest degree, x squared. So factor out a 4 from there, we get 4 times the quantity x squared minus 10x. And then do the same thing with the y terms. So 9y squared, that tells us that 9 is the leading coefficient. Factor out a 9. So 9 times the quantity y squared, and minus 2y, because 9 times 2 is 18. Alright, and that's equal to negative 73. Now you might wonder, why are we even doing this? Why are we factoring out the leading coefficients? And the reason for that is that this makes it easy to complete the square. completing the square will give us these x minus h squared and y minus k squared terms. So our next step here, step number 2, is to complete the square. So to complete the square, let's rewrite this equation again, but leave ourselves a little bit more room at the end of these parentheses so that we can stick in another constant term. So we'll have 4 times quantity x squared minus 10x plus something, we'll fill in that something just shortly, and then plus 9 times the quantity y squared minus 2y plus something. And that's equal to negative 73. So what do we stick in here for the somethings? Well, look at x first. The way to get the something here that makes this a perfect square is to take that x term, which is negative 10, divide it by 2 and square it. So negative 10 divided by 2 is negative 5, then squared makes 25. Do the same thing for the y terms. Look at that middle term, the coefficient on the y, that's negative 2. Divide that by 2 and square it. So negative 2 divided by 2 is negative 1. Square that, you get 1, so plus 1. And before we jump into factoring these two expressions, remember that whenever we do a change to one side of the equation, we have to do the same change to the other. So in this case, we've added 4 times 25 and 9 times 1 to the left side of the equation. So we also have to do that to the right side. So we have to add 4 times 25 and add 9 times 1. All right, so now let's go ahead and finish completing the square. So take these terms here, the x squared minus 10x plus 25. That is now a perfect square. That's the perfect square x minus 5 squared. And then for the y terms, this is also a perfect square. It's the perfect square y minus 1 squared. And if you add up all this stuff on the right-hand side, you should get 36. Alright, so now hopefully you can see that our equation is starting to look a lot more like this ellipse form. We already have our x minus h squared and our y minus k squared, but we still do have a little bit of work to do because here in this ellipse form, the right-hand side is 1, whereas here in our current form, the right-hand side is 36. So let's go ahead and proceed with our third and final step in converting to ellipse form. The third and final step is to divide the whole equation by 36 so we get a 1 on the right hand side. So let's go ahead and do that. We'll have 4 times x minus 5 squared over 36, then plus 9 times y minus 1 squared over 36 equals 36 over 36, which is just 1. Now we're even closer, but again, we're still not quite there yet. One issue is that we have this 4 and this 9 in front of the square terms, and in the actual ellipse term here, we don't have any terms in front of the square terms. So we need to simplify this equation a little bit so that this 4 and this 9 get lumped into the denominators only. But that's pretty straightforward. We can just simplify both fractions. 4 over 36 is just 1 over 9. You can just divide top and bottom by 4. So this can become x minus 5 squared over 9. And then we do the same thing for 9 and 36. Divide top and bottom by 9, you get 1 over 4. So y minus 1 squared over 4 is equal to 1. And hey, we're so close to being there. The only issue now is that we have an a squared and a b squared in the denominators, and here we just have 9 and 4. We want to write these as squares. And it's easy to tell because these are perfect squares. 9 is just 3 squared, so let's write it like that. So x minus 5 squared over 3 squared, and then plus y minus 1 squared over 4 is just 2 squared. And finally, now this equation is in the ellipse form. H is 5, k is 1, a is 3, b is 2. So now let's go ahead and pick out the information we want. The information we want, first of all, is the center. The center is just h comma k according to our ellipse form. H is 5, k is 1, so center is just 5 comma 1. Okay, and then what is the major axis? Well, the major axis is just twice the semi-major axis. And what is the length of the semi-major axis? Well, we know from ellipse form that the length of the semi-major axis is the larger of A and B. So what's the larger of A and B here? A and B are 3 and 2. The larger of those is 3. So major axis is just 2 times 3, which is 6. And then how about the length of the minor axis? Well, the minor axis is just twice the length of the semi-minor axis, and the semi-minor axis, the length of that is the smaller of A and B. The smaller of 3 and 2 is 2, so 2 times 2, which is just 4. So there we go. There is all the information that we wanted: the center, the length of the major axis, and the length of the minor axis. And there we go. Now we know how to find the equation of an ellipse by completing the square. In the future, we'll also learn how to find the intersection between an ellipse and the x-axis or the y-axis or any general line.